just miss to sorry to I missed to start recording. Thanks for the reminder. In any case, if you want something, please raise your hand and let me know so I can help you for clarify a bit more. So basically, so the content would very easy. It's not too complicated. It's a bit easy, but it's an undergraduate work, so you should give some of effort or a bit of effort to get a clear and detailed understanding. Right. So we'll start our discussion related to this topic. So what are the elements of communication systems? Basically, we should have basic elements of transmitter, a medium, and a receiver. So they simply send and a medium to send the information to the other end. There should be a person or a mechanism to receive the information. This is the normal situation. As an example, you are speaking from here, your voice is in here, this voice should be transmitted to the other end, then there's an ear to receive this information. That's how the real communication happens. Extract same communication mechanism happens in digital environment. The difference might be in a high level, the medium of communication. Uh, Usually, for our communication, we use air as the medium for communication. That's the usual mechanism or the usual medium. Once it comes to these computer technologies, the usual mechanism would be wired or wireless. Wired in the sense it's not something that what we call this metal product. There might be even fiber optics over also. It's kind of like it's a solid object. Right? A wireless communication, basically we could have air or not even. Right? So without air even we can communicate. So we should find there is a physical combination in between the transmitter and the receiver. If there's a physical combination, then we can simply categorize as a physical communication, as wired communication. If there's no physical communication in between transmitter and the receiver, so we can categorize that medium as wireless communication. So I think that kind of a high level classification would be much easy to understand this kind of a complicated scenario. Right. So I am going to build all of these discussion on top of the basics that I have discussed in here. Right. So consider that two people are talking on a street. Right. So what happens? There's a signal, voice in that communication. So it transmitted to your friend. So this is a speech signal communicated through air as a communication mechanism. Right. So we'll start our discussion. First of all, wired communication. Signal travels through wire in electric form. So what happens in here, this wired communication, we have a specific uh, physical medium. More specifically, it's like the usual scenario in electric communication is a metal. It might be copper, it might be any other product, aluminum, copper, or zinc, or any other metal related uh, medium is helping to transmit these electrons from one end to another end. So basically need a device to convert speed signals to electrical signal at sender's end. Now, as an example, I'm speaking here, right? I'm speaking here, and this is my microphone. So there is a microphone. Uh, all of my waves, my sound waves are captured in here. This captured wave, these waves are analog waves. Okay, these are analog waves. Analog waves means we don't have a specific range or a specific direction, a specific mechanism for this transmission. It's like if we diagrammatically represented the energy or the frequencies, any other kinds of things could be like this kind of a graph we can easily in between the frequencies of our voice. Okay, so what happens in here, our voice is not a digital product, it's an analog product. So basically the variations are quite high, that's the reality. So what we need to do is we need to convert all of these digital sorry analog transmission or the analog signals into digital signals. So need a device to convert speech signal into electrical signal at the sender end. So sender end this analog information should capture and it should be converted into digital, because the data transmission can happen in our environment, means the computer environment, basically electrical environment, basically using ones and zeros or digital signals only we can transmit it. We are unable to transmit the analog data as it is. So what we need to do is we need to convert into this uh, analog medium to digital medium. We'll discuss how this transmission is happening and how these things are going on in here and there. But general understanding could be more than enough to that my voice is analog and it should be converted into the digital. Then only the transmission can be happening here. Need another device to convert electrical signals back to speech signal at the receiver's end. So this data transmitted as ones and zeros. The all these manual, sorry, the analog data is transmitted into digital. Now the digital data goes through like this, like so ones and zeros. There's all of these things. So this is my analog data from my voice. So this is my voice data captured from a uh, microphone. Now it was converted using, there is a specifically if you take analog to digital converter to convert into digital waves. So at the end of the day, you have ones and zeros, a nice representation of these ones and zeros. So a sequence of ones and zeros are transmitted to other end. So this was captured in here, the other end, then it's nicely captured by digital to analog converter. This is another device to transmit the data. This digital to analog converter could be able to convert all of these digital waves or digital signals into analog signals. So again, we can hear, because for a human, we are unable to hear this voice, or sorry, this ones and zeros as it is. We are unable because we are not machines or robots. So we are humans, so our ear is much uh, sophisticatedly developed only for these kinds of transmissions, right? These kinds of information capturing. So all we need to understand is these kinds of transmission mechanisms. So these devices called transducers. So this is the key point that you need to learn. What is a transducer, right? So make sure to write a small note in your book related to this topic, transducer. So this is very important. As an example, microphone, speaker, etc. If you do have any questions, guys, please let me know. I can pause and I can stop my discussion. I can give an answers, because this is a small class. I have a limited number of students in here. It's not a big deal. It's just 12 students, so I can easily answer students' questions without any problem. So just let me know if you have any questions. Then I could be able to help you. Now, electrical communication system could be now a bit level of in another level of situation. Basically, we have input message and this input transducer. Then there's a transmitter, then transmission medium. There might be noise, electric noise, obviously. Then there is a receiver, then output transducer. So basically, we have output message. So the input message is basically again analog data. Again, here we have analog data. In between this transmission mechanism onwards, we have digital data. So all of this digital data is transmitted via a medium. It might be a wired medium or it might be wireless medium. So it might be wired or wireless medium. There is a transmitter and there is a receiver to transmit the data and to receive the data. Input transducer converts the original information signal into an electric, uh, basically an optical systems. Input converts into optical signal. An electrical signal may be any one or more of the following types, which are time variant signals. Time variant signals means whenever the signals, the values of the signals, values of the signals means frequencies or any other parameters are changing with the time. As an example, once I started my discussion, my frequency, my voice, my vocal cords are generating thousands of frequency ranges, in the sense thousands of words. All these words do have different kinds of frequencies. Then only we have this kind of a nice transmission mechanism can be happen. Okay, so it's based on the time. T equals to 0, I have started. T equals to 0, I have started. Then T equals to T equals to 1, we have another kind of voice range. T equals to 2, we have another voice range. And T equals to T, we have another voice value. So basically we have a nice time variant signals. Time variant signals. Some of the time I'm speaking a bit louder. Some of the time I'm keeping intervals or spaces in between the words. Then you can easily understand. All right, with the time my frequencies, my energy is changing. It's not a constant value, it's dynamically changing over the time. Now these are the types of signals that we need to understand. Probably I think now you have almost some understanding. We have analog and digital signals separately. Analog signals, if we take with the time, with the voltage, if we convert these analog signals into voltages, it might generate a sequence of voltages along the time, and it's not nicely graphed. Like it's like a complete mix of the ranges. Right? So it's a mix of ranges. It's not just like nice information. You can see it's like changing over the time in very frequent manner. So it's changing over the time. It's not a specific value. It's just a range of values we have. But once it comes to this digital signals, we have a nice range. It might be high power or low power. Sorry, should be nice line, guys. Sorry, I'll try to draw a nice line. Something good, right? And right, something good, right? So here, this is the value 1. This is the value 0. We have high voltages and we have low voltages. That's it. If it is in here, if we take this is the voltage of 500, I'm just assuming this is 500, then a range of 500, 499, and 400, 300, 200, and sometimes 100. 500 to 100, we have a range of voltages are generated. Similarly, all of these values do have different kinds of ranges. In here, there might be around 300 to 200 to 300, around a range of values. Now, once it comes to these digital systems, we don't have such kind of thing. It's just basic structure or basic information that all you need to understand, right? So it's much easier and it's much convenient for you to understand what kind of situation will happen in these analog and digital signals. Any questions up to now? We haven't discussed a lot. We just spoke. There is a conversion procedure, and we have types. We have different devices to convert analog data into digital data. Then we understood how this changing over the time. That's all we understood up to now. Any questions? All good? All right then. Communication channel. This is the next topic that we need to understand. The channel provides the connection between the source and the destination. Now you know what is the source and what is the destination. Source means where the power or the energy or the waves or simply the voice, in general terms voice or noise or whatever, sound in general terms, where it generates, this is the place that it generates sources, and destinations are where it's ending, so where it's ending. So communication channel provides connection between this source and the destination. Now you know a connection might be a wired or wireless communication, right? So that's a very high level differentiation. Now, if we take a bit different angle, this is the path between a transmitter and the receiver. So basically, it's a transmission and a receiver. So same thing like a source and the destination. So we have broadly divided into two categories. One is guided media, the other one is unguided media. What are the guided media? Wired or bounded media. That means we have a specific direction. The electrons should transmit it. The electrons should transmit or move towards a specific direction. That's the guided media. As an example, twisted pair, coaxial, fiber optics. Every time we know where, from which direction it goes, from where to where it goes, the electric power, where to where it goes. We know the starting and the ending. So there's a guided media. Through the medium, electrons or the power should transmitted in a specific direction. It's like a bounded environment. So we are unable to change that direction or change the location of this data transmission or the power transmission from one into another, like what we want, but it's like predefined. But once it comes to this unguided media, it's wireless media basically. We don't have a specific direction of data transmission. So usually it's basically a circle kind of data transmission. If you take any wireless device, as an example, think your mobile phone, assume that you are in a location, this is your room, and there are two mobile phones that you have, right? So you have two mobile phones that you have, mobile phone A and mobile phone B. Assume that you are transmitting set of photos from device mobile phone A to mobile phone B. While you transmitting these photos, you received a call. Uh, the call is received to phone A. So what you do, you take the mobile and you are walking in this area. You are walking in this area while you are speaking. While you are speaking, still the data transmission is happening. We haven't paused it, we haven't stopped it. So what happens in here, the data is continuously transmitting without a specific direction. As an example, once you are this location, the connection, the power waves are generating as it is without any difference. So this is the wave that it generates. That's I told circular waves. It's like a circle. I have drawn only a part, but actually there is a circle. So this is the circle. This is not this much, probably this much of circle. So similarly, we have another circle, another circle. It's like nicely diagrammed it should, but it's a bit hard. So even if your device, this B device is in another room, if you take this B device, for an example, your sister or brother took this mobile to his room, it's located in this location, without any problem, the transmission is happening. While you are walking, you can transmit the data. The reason is these waves are directed to this direction. So who defined this direction? No one. This data directed to this direction, this is like to this is like to this. It's like a sphere, 360 or everywhere, up down every time. So I have drawn a 2D design. If it is a 3D, it's like a nice ball. You are inside, your device is inside a ball. Assume now the data is transmitted to any place around you. Clear? So that's the focus on this wireless media or unguided media. We don't have a specific direction. Instead, it's just flowing throughout everywhere. We have no guided at all. So what we are doing is we are generating thousands of millions of waves. Then whenever we capture the other end or the receiver, then we could be able to transmit. By capturing, it's not specify you need to static or you need to keep the device as it is while you are traveling in this any area. If it is capturable or if it is a receivable area, then the transmission could continuous as it is. Any questions? Right. What is noise? Unwanted signals that disturb the communication. External noise and internal noise. Noise limits the operating range of systems. Noise affects the quality of signal. Now, once it comes to this data transmission, whether it's wired or wireless communication, there are some noises generating. What are these noises? As name implies, some of disturbances. How these some of examples, so how these kinds of situations could be happen. An example, assume an example. So the basic or the easiest thing could be think we have a noise mechanism due to the electromagnetic fields. Once it comes to this electric power is moving to a direction uh, through a wire. We have electromagnetic waves are generating. I think you learn all of these things grade 11, 12, grade 12, 11 or 12 around. Right? We have learned these 2 months, we learned these theorems and so on and so forth. While the electric power is transmitted to a direction, we have electromagnetic power automatically generated. So whenever there are some process, if there are two lines, there might be some additional uh, connection. So additional range of uh, process or capturings in between these cases. So what could be happen? There might be an additional noise, can be additional data set, additional information, additional uh, some cluttered out area could be generated due to this kind of thing. So this is known as noise. Clear? This is known as noise, something that generated due to internal or external factor. As an example, think uh, there is a, like for an example, think wireless communication. So we have a transmitter. It's located in somewhere. So this is the transmitter, right? So there is a heavy thundering situation, heavy thundering. So while you are getting a call, this additional external factor could disrupt your communication. This is the wave that it generates. So this wave was interrupted due to an external factor. That's the that's known as this external noise. Internal noise usually generated because of these electromagnetic effects. While the electricity moving towards a wire to a direction, what happens? It could generate an additional phase of power. This power generates an additional noise, an interruption occurred, an interruption generates due to this internal or external noise. Questions? Anything that you understood or not? All good? Okay. Now, you should understand if we are using optical systems also using the same concepts. There are no main other concepts. Right? There are no other main concepts, like same concept could apply in here. And what are the issues? What are the impacts of this noise? This noise definitely a disturbance for the transmission. So some interruptions could be happen, and sometimes our quality of the service could be disrupted because of this internal or external data transmission, or sorry, the what we call this noise. Any questions? No? All right. So next we'll discuss bandwidth. I think this is very common or buzzword in current environment. Bandwidth is a term actually that is usually used in telecommunication or computer networks, and it refers to the amount of the data that can be transmitted over a network connection in a given period of time. Usually this bandwidth measured with bytes per second, bytes per second, or kilobytes, megabytes, gigabytes per second. And in general, if you are speaking in general, higher bandwidth allows for data higher, faster, higher or faster data transmission, and it's enabling quick downloads and so on and so forth. That's why you are always selecting high bandwidth internet service provider, isn't it? That's the reason behind that you are selecting a nice transmission mechanism for our work. Basically, if we take this signal bandwidth, it's another concept. This bandwidth can be broadly divided into two. One is signal bandwidth, the other one is channel bandwidth. Signal bandwidth is a specific scenario, and channel bandwidth also a specific scenario. You just deep dive, guys, on these topics. Basically, signal bandwidth is a range of frequencies that makes up a signal. Now, this is the point that we need to understand. The initial part that I spoke with you, the general concept, but once it comes to more specific context, we should understand signal bandwidth is a range of frequencies that makes up a signal. As an example, human voice is a specific range, and we can hear a specific range. Some commercial speeches, mains electricities, and so on and so forth. The other part, the part number two, first one is signal bandwidth, the second one is channel bandwidth. Channel bandwidth is information carrying specific the capacity, measured in cycles per second, right? Cycles per second, how much cycles that we are taking on this transmission. In digital transmissions, it measured bytes per second. That's the point that I spoke with you. Now, you know, this kind of in bandwidth, it can be broadly divided into two parts. One is signal bandwidth, the other one is channel bandwidth. And in the digital transmissions, usually it measures using bytes per second. Sometimes it might be if it is higher bytes, as an example, kilobytes, megabytes, or something, it could be calculated according to that value, because bytes per second is the lowest measurement that we know. But megabytes, kilobytes, or gigabytes, or something much more beyond might be occurred according to the situation. Any questions? Any questions, guys, up to now? Anything needs to clarify? All good? Ask any questions? No? All right, thank you. If you don't have any questions, I'm happy with that. Well, there's a question, presentation slides. I don't think so. I can share these presentation slide, guys. but I have started the recording, so I will share the recording with you. I think you know how to download. So all the slides are in there. So I'm not sure whether I can, is this authorized to share with students or not. So please contact your unit coordinator and check the possibility to get the presentation slides, because I'm not authorized to share these slides without the permission. So what you can do is you just check with your unit coordinator and then ask the slides. If it is authorized, he or she could be able to share with you. Unless, no worries, you have all the slides in the recording. Right? So I think you know how to download these slides, sorry, videos from SharePoint location. If you do have any issues with that, let me know, then I can do something for you. Right, next topic that we need to discuss is modularization techniques in communication systems. Now, modularization is a nice context. It's a nice context. If I give very high level discussion before we dive into this modularization, uh, modularization refers to the process. Give me a second, guys. Right. So sorry for the disturbance. It's an important call. That's why I just answered. Right. Come. We'll discuss what is this modularization. Modularization. We'll divide this discussion into module. Right. Modules are converting. Modules are arranging. Modularization means creating models. Simply, that is creating models. What kind of models? Chunks of electronics, chunks of electricals, ones and zeros. As an example, assume you're going for a picnic. You're going for a picnic. Now you have cheese, you have bread, you have butter, you have fruits, you have knives, you have all of these XYZ clothes and everything. So what you're doing, you create a module from this, isn't it? You pack everything into a one complete package. This process is known as modularization. I think now it's much clear for you. This packing, in this case, you have food, vegetables, all these XYZ factors. So once it comes to computational technology or computer technology, these are bit codes, one zeros, packets of ones and zeros, bunch of packets of ones and zeros. Okay, so we'll discuss a bit more on this. So basically, process of modifying carrying signals into encoded information from transmission over communication channel. So basically, what happens in this scenario, uh, you need to modify the carrying signal into encoded information for transmission over communication channel. That's the point that you need to memorize. So it's a carrying mechanism. It's a carrying of a signal by encoding. So we can't take as it is. As an example, think water. You need a water bottle, isn't it? You need to have a more sorry, water bottle, at least a cup. Unless water will spitter over everywhere, we can't take water from our hands or something, right? So we have to have some of cup, bottle or something. So it's a carrying mechanism by encoding. We need an encoding mechanism, a device, a mechanism is transmission. That's the encoding. Now, for an example, assume I think you know this encryption and other stuff. If you don't know, no worries at all. It's just changing the words according to easier mechanism. As an example, if you just map the same thing that what was we discussed earlier, we was discussed that we have this nice uh, analog data. So this analog data would not transmit it as it is. What we are doing, we are going to take ones and zeros from this. So a sequence of ones and zeros. What happens at the end of the day, we transmit these ones and zeros, but is this and these are same? No. And is these two are different? No. These are same? No. These are different? No. So what's the reality? We have same thing, but in a different mode. Who transmitted, who converted this into this? By encoding. We have a mechanism called encoding. So it's just a transmission mechanism. So that I think that makes sense for you. So basically, we have uh, to discuss this modularization in various forms of like radios, televisions, wireless networks, digital data transmission. Many other aspects might be there. So basically, in modularization, carrying signal is typically in a high frequency waveform. As an example, we'll take sine wave. So it's capable of traveling long distances with minimal signal losses. That's the point that you need to understand. Because we want to take or we want to travel into a long distance without any interruptions. So what we need to do is we need to take a high frequency waveform. That's the power that we can do. That's the main attribute or mechanism that we can do. The transmission to be transmitted, sorry, the information to be transmitted, known as modulating signal. So simply, it's modulated. As an example, we created a bag or backpack, right, in onto a carrier signal by varying one or more properties. We can have many properties, guys. What are the properties? Examples of properties: amplitude, frequency, freeze, or any other factor. Uh, the modulating signal can represent different forms: audios, videos, digital data, and many things. And modulating the carrier signal, the information is embedded into signal and can be transmitted efficiently over a communication channel. Right? In the other hand, at the end of the receiving end, we want to open all of this back, isn't it? This is known as demodularization. We want to open the backpack and then only we can do whatever we want. So some of techniques we are going to discuss, like amplification modularization, frequency modularization, phase modularization. All of these things are like, I think it's much common. The difference is the attribute that we are focusing. If it is amplitude modularization, we are mainly focusing on amplification and stuff. If it is frequency modularization, we are mainly focusing on frequencies and so on and so forth. So it's a critical role, and it allows reliable communication across various forms. Media is key aspect of modern communication systems, right? So that's the point that we need to understand very well. And first we need to load or embed it in high frequency. I think your book, all of these things are discussed very well, but I want to give a brush up again. Information is first loaded, or simply it's embedded. So we create a backpack, right? High energy signal known as carrier signal. This is the carrier signal that we need to focus on. What is demodularization now? I think it's much clear. Demodularization means taking the backpack back to the normal situation. So what happens in here? We have modulated signal, then we have a carrier signal. By combining this modulated signal and the carrier signal, we could be able to convert it into demodularization. So this is the information. I think it's something on a bit. Information is back to modulating signal. So this is the modulating signal. I think it's much easy if you can take both images into one place, then much easier for you to understand. Right. So this is the modularization process. Now I think you can easily understand. Modulating signal is going back to the modulating signal. This is the modulated signal. Initially, we added the carrier signal. This is the adding. So we have modulated signal. This modulated signal comes to the end, and we use the carrier signal again to take it out. Now again we have modulated signal. So uh, x is equals to x again. So we have some processing happens behind the scene, but at the end of the day, it's as it is. We have no issues with this modularization process. Right. So I think you don't have any questions. If you have any questions, let me know, guys. All right. If you don't have any questions, we'll proceed. Modularization and demodularization. We have a microphone and modulator, and we have amplifier to amplify, to expand it. Then we want to share it using an antenna or some other mechanism. And the receiving end, we have a receiver, then again for for a suitable amplifier and demodulator. So this is the receiver and audio amplifier to improve the noise, improve the sound. Sorry. Then we have loudspeaker that generates sound noises throughout. Then we can hear. This is the high level overview of this modularization and demodularization. What is the analog modularization? Now, analog modularization up there, these are kind of types of this modularization again, like easy things. Use sinusoidal signals as carrier, and it can be described like amplitude and angle, frequency and phase. In simple terms, frequency and phase. These parameters of high frequency carrier are varied for transmission information. Yeah, these are the basic things that related to the analog modularization. We have very general law. We don't need to bother a lot. Angular modularization can be again divided into frequency modularization and phase modularization. A bit more detail, we can divide all of these things into much more detailed in here and there. Some of examples. Now, again, this analog modularization can be divided into, and divide into a bit more further amplitude modularization, frequency modularization, and phase modularization. What happens in this case, amplitude modularization focuses on the amplification of this modularization process, and frequency modularization again, phase modularization, it takes specific phases for the modularization process. That's the point that you need to understand very well in here of this analog modularization types. So if we take amplitude modularization, right? So this is the first part of this one. Right? So this is the first part of this amplitude modularization. Amplitude modularization, amplitude of a carrier signal is varied according to information signal, modulating signal. Right? So what happens in here, we have a carrier wave. We have a carrier wave and we have a modulating wave. We have a modulating wave. Then we combine these two. And you can see this range is nicely created according to this shape, right? According to this shape. And similarly, that we have an additional phase. So the additional phase is generated here. The information is full, or the power is full with the carrier wave. So if we take in general terms, if I trim it in here, so it's nicely have this kind of curve. It's too much far away. It's too much far away. I try to draw again. Right. So you can see this is the area that it covers. Right. And if we do another wave, it's like this, goes a bit high. Right. Clear. Now what happens here? We have nice small modules. So we have nice small modules in here. So this is the structure that we can see, this modularization. Right, you have a question. What I'm going to do is I'm going to uh, give an opportunity to you to solve this question later on. You could able to go through your documents and stuff, because at a glance I don't think so you could be able to solve this problem, right? So your answer is available in the course material page 72, so you can see how it was solved. And this explanation is in lecture 2 video presentation slides available in the LMS. So you have to watch it if you haven't done, but the expectation is before you are joining to this session, you have gone through all of these things. Right. So I'm not spending time for this one, guys, because it takes time to solve this question and explanation. So we have very limited time, so you can go through quickly and you could able to understand a bit more. If you are unable to understand, let me know. Then I'll give a try to solve your problem. Right. Frequency modularization. Again, we'll discuss what is this frequency modularization. Frequency modularization is again an easy mechanism that the frequency of carrier is varied according to the modulating frequencies. So you can see if the frequencies are much near, then the carrier wave is becomes to a much closer area and so on and so forth. Then the carrier frequency can be changed. It is called frequency deviation of FM signal. The carrier's instantaneous frequency deviation from its unmodulated value varies in proportion to the instantaneous amplitude of modulating signal. So these are some basic things that you can go through, and it's just basically memorizing. So you just go through again, and I think you have almost understand everything very well. I just want to recap you. We have another question to solve this question. This is another easy question, guys. It's not a hard question. You can check your page number 75, and all the calculations are explained in the lecture 2 video presentation. So it's in LMS. So please give a try to uh, elaborate for you. If you are unable to solve this question, let me know. I'll give a try to help you a bit more to solve your complicated problem. Right. So we'll go to dive into the third one, that is phase modularization. Phase of carrier signal is varied according to amplitude of the modulating signal. Thus, and we have cos omega c to t and ft to a cos omega t plus phi. So, you know, sometimes it might be a bit hard for you. Don't worry, guys. That's not too complicated, just basic equation. Digital modularization. What is digital modularization? Digital modularization, same as the analog modularization, except the modularization signal is bit stream, consists with logic 0 and logic 1. Then it will be embedded to high frequency carrier and transmitted. Basic digital modularization types. 3 types are discussed in here: amplitude shift key, frequency shift key, and phase shift key. These methods are used for different applications according to the available bandwidth and the data rates that need to transmit via the channel. That's digital modularization. Let's discuss amplitude shift key. Anyone knows what is this amplitude shift key? Anyone? I spoke a lot. I would like to give an opportunity for you. amplitude shift key. Yes, anyone? No idea? Right, no worries. Amplitude shift key is a modularization technique that used in digital communication systems. And basically, this is one of popular mechanism, right? And this is varied to represent digital data. The amplification of the carrier signal is varied. So that's the point that you need to understand. It is a form of amplitude modularization, and the amplitude of the carrier signal is switched between two or more levels to convey the binary information. So it's something that happens in here. You can see in the diagrammatic, it's just modularization signal like this. And the carrier signal is typically a high frequent waveform, like as an example, I told previously the sine wave. The digital data to be transmitted is is representing actually by different amplitude levels, carrier signals, levels of the carrier signals. For an example, think one amplitude level can be represented uh, by the binary 0, and another amplitude level can be represented by binary 1. On the other hand, the receiving end, the signal is demodulated by detecting the decoding the different amplitude levels to recover the original digital data. This can be achieved using various techniques. As an example, coherent demodularization or envelope detection. So this is something beyond the discussion. I want to give some additional information for you. And it's a relatively simple technique, guys. It's very easy, but susceptible to the noise and inference, since the variations in the amplitude can be easily affected by the channel conditions. As a result, this is a commonly used applications with relatively short transmission distance or scenarios where noise is not significant concern, because as I discussed previously, noise could directly impact for the wave. Clear? So the next one that I would like to discuss is some of applications in front, the remote controls and fiber optical transmitter and receiver and blah 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 blah. Lot. Right. The next one is frequency shift key. Anyone? Guys, speak with me. Unless it might be lazy for you, you might feel it's too complicated, too sleepy. Huh? Yes, guys, speak with me. Tell me your ideas, your thoughts, unless you might think, oh my God, this subject is extremely hard. Uh, no idea. I think you haven't go through the videos or the book before joining to the live discussion. That's a best practice, guys. Make sure to go through the book, read it very well, and make sure to go through the videos, then join to this one. That makes sense for you. Somehow, if we have a small discussion related to this frequency shift key, is a digital modularization technique that used in communication systems to transmit data over carrier signal. In frequency shift keying, uh, in there actually the digital data is represented by different frequencies of carrier signal. So frequencies are the matter. So you should understand. Frequencies are the matter. Usually we have two frequencies used to represent the binary states. These are known as mark and the space. Usually mark and space is the common thing. Mark frequency represent usually by binary 1 and white. The space frequency is represented by the binary 0. So the transmission, when data is in digital data, the carrier signals frequencies switched between two, right? So it's switched between two states. In the other hand, in the receiver's end, this frequency shift key is demodulated by detecting the frequency changes and the decoding them back into the original data form. So this is usually performed using techniques like phrase locked loops and so on and so forth. I'm not going to discuss a bit more on this. It might be a bit heavier for you. Yes, any questions, guys? Now sleepy? Jump twice and have a quickly go out and have a cup of water or tea and come, guys. It seems that people are leaving for some reason. Now it's lazy, sleepy. I know it's heavy for you. Slam hammer into your head. Quickly run, stand and go out and come. 2 minutes, 2 minutes small break. Quickly come, guys, unless you might be sleepy. 2 or 3 minutes, quickly go out and come. Right, we'll quickly complete the rest of the slides now. Phrase shift key. What is phrase shift key? Again, like similar thing, right? So once it comes to this phrase shift keys, focusing on phrases, right? Change the phrase of carrier depending on the information or the modularization, modulation, sorry, modulation. Used in ADSL, broadband modems, mobile phones, and satellite communications is, of course, it's a broader context. It's a broader context actually. Once it comes to this uh, phrase shift key. So it's used in communication systems to transmit data over a carrier signal in phrase shift key. The phrase of the carrier signal is varied to represent different symbols or bits of the digital data. Yeah, right. So I think it's much clearer. Each symbol or what we call this bit is associated with specific phrase shift of carrier signal, as well as commonly used PSK schemes include binary PSKs, differential phrase keys, and so on and so forth. There are a lot to understand. You just calm and carefully, you just follow these things, then you can understand easier. Some of advanced digital modularization techniques and commonly used techniques, as I told, binary phrase key shifting and so on and so forth. So I have covered everything related to today's discussion. Right. So now you can explain the importance very well in modularization and the process of modularization, demodularization. You are now expert, right? So you know every edge now in this case, and you should be clearly explain all the amplitude modularization and effect of modularization index in detail. I think we have discussed all the things in that few time. Compare analog and digital modularization. Now it's like a piece of cake. You know all of these things. Explain the different modularization techniques and unique features. Identify the applications related to each modularization technique and so on. So some of signal power communication information related to this is done. Yes, any questions? Any questions? Any questions, guys? All good? Very clear or complicated? This is not something easy. It takes a bit of effort, guys. Right? It takes a bit of effort. Definitely, you should have sufficient time and explanation, self-explanation, and then only you can understand all of these things in and out. At a glance, it might be a bit complicated, but I'm pretty sure after a while you should be able to grab all things. These are not very hard or complicated things to discuss. Right? Any questions? No?
No, sir.
All good. All right then. If you don't have any questions, we'll wrap up for today. We'll, if sometimes we'll meet in another subject or somewhere. Good luck. Do all the exams and stuff very well. Presentation slides, I'm not sure dear how to share. If there's any possibility, I'll share as a chat, but somehow I think video is accessible to you, so it's recorded, so you can go through these things again and again. But I'm not sure whether I can. Somehow you just drop an email to your unit coordinator, then probably you can get it if there's any possibility, because I'm not authorized to share the teaching materials with the students if I'm not mistaken, because it's not my material, it's university's material. It's not prepared by myself. So intellectual properties are unable to transfer as it is. So it's not under my context. If I have created, I can share it because it's my knowledge, my effort. This is not mine. So it's a violation of intellectual properties. So I can't share the presentations as it is. Right. Somehow you just give a try by discussing with your course coordinator, then probably you can. All right, then, if you don't have any questions, see you. Bye bye. Good luck. Do the examinations very well.
Thank you, sir.